Okay, everybody. So welcome here. We are now doing section 1.4, and this is going to be on page 34. So this is going to be our compound interest, part 3. Specifically, this is looking at present value. This is on page 34. Okay. So really simple. The concept here is quite simple. And I'm going to refer to actually either of these ones here, right? So in 5 years after graduating from college, Cal wants to spend a year traveling in Canada's 3 territories. And he plans to start in Yukon and then travel east to the Northwest Territories and to Nunavut. Cal has determined that he will need at least $15,000. So he knows how much he's going to need in 3 years, in 5 years. And to reach his goal, he wants to invest his money now. He has chosen a GIC at 7% compounded annually. The key question here, however, is how much does he need to invest now so that he will have $15,000 in 5 years? So the concept here, so present value is looking at how much is needed to be invested now so that a desired amount is achieved in the future, right? So in this case, he wants to know, he wants $15,000 in 3 years. He has a 7% interest rate. It is compounded annually. So we want to know how much he has. So we already know what the A is. We know what the I is. We know what the N is. We know what the T is. What we don't know is the principal. We're trying to find the principal. So it's discovering the principal's amount. And now basically speaking, we're finding things other than the investment. We're finding, so sometimes we'll have to find the number of years. Sometimes we'll have to find the interest rate. But it's finding things other than the investment is what this is. So that's what the concept of this is. And so what we do is we find this using this formula here. Oop, do that a little bit better. So the future value, let me just put this in here. So make sure you guys get that down. I'm not going to reintroduce P or I or N. You guys have that now, or A, so on and so forth. But the future value of an investment that earns compound interest, given the principal or the present value, interest rate and compounded frequency can be determined using this compound interest formula. That is the fancy way of saying is we can find stuff with that formula. We can find stuff that we can find anything with this formula. As long as we have everything, if we're only missing one thing, we can use the things we know to find the thing we don't know. It's that simple. So just like before, right? Actually, I'm not going to get you to like box this and stuff, but I want you to know this is how we do it. Now, if you're good at algebra, this is going to make sense to you. If you're not good at algebra, you will need to refresh your skills. Please reach out to me. But two, I will give you some like cheat codes here a little bit later on in this lesson. But specifically, I'm just going to substitute in the stuff I know. $15,000 is equal to, I'm trying to find P. I know that it is 1 plus 0.7. And this is all to the power here of 3. So what I need to do is I need to get P by itself here, right? So I'm going to, first off, divide both sides. By this 1.07 to the power of 3. Divided by 1.07 to the power of 3, which means canceled out, and we'll get something over here, right? So we're going to get $15,000 divided by 1.07 to the power of 3, and all of that is going to be equal to P. Divided by, I'm going to use my fraction, right? Fraction button, good. Divided by 1.07. Oh, to the power of 3. And I can see it's going to spit out an amount of $12,244.46 is equal to P. So this is saying that, hey, if you invest this much money, 12,000 and some dollars over 3 years at 7%, you will then end up with $15,000, right? So that's what this is saying here. Okay. If I know, if I'm missing one thing and I know everything else, I can use the things I know to find what I don't know. It really becomes that simple. But involves some algebra work a lot of the times. So everything I'm going to be showing you is deduced from this formula, but it's going to save you some of that work. So later on in your book here, I'll get you to scroll down a little bit. I think it's page 38 or 39 here. I'm going to actually jump straight to the in summary page here, and we're going to work backwards from this stuff here. Okay. So I want you to go to page 39, and I want you to write this in your notes here. Make sure it's really clear and easy and solid here. Okay. So pause the video, write it down. 3, 2, 1. Okay. So first off, everything here comes from this formula. Everything here comes from this. So this was used to create these formula. Okay. You don't need to know that. You don't need to know that, but that's a helpful thing. Everything you need can be deduced from this formula. But if you don't want to deal with the algebra part of it, you can use these other ones here. Okay. So I really want to make sure you're aware of what this is. I want to know, first off, this one here, this first one, this is used to find P. This first formula here is to find the present value, the principal. For this question up here, I wanted to find P, right? This is what I was trying to find. I could have used this formula. It was A, your investment amount, in this case, $50,000, divided by 1 plus I over to the power of n. Well, that's what this is, right? So all I did was I took my investment amount divided by the interest rate and the years, right? So that's what this is. This is literally what this is right here. But what if I wanted to find something different? What if instead I wanted to know if I knew this $12,000 figure, but what if I'm like, well, I want to know how many years? I want to know what the interest rate is. I want to know how frequently it needs to compound. I want to know just like the ratio between the investment and the principal and blah, 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 blah. So what if I want to find something else? That's where these ones come in. So this one here, look at what you're trying to solve. This one, first one, trying to find A. Trying to find the investment, the total amount, right? The total amount at the end of it. Look at P. This is the same one up above here, right? This is trying to find the principal or the present value, PV, present value. Look at this one here, A divided by P. A divided by P. I'm taking my investment and I'm dividing it by the principal. This is seeing how much larger it is. This is seeing how much larger. So maybe it's, maybe it's 2 times bigger or something, and so on and so forth. So that's what that is. Here, let me do this. It's just a little bit, text a little bit smaller. Whatever. Good enough. Okay. So you have a bunch of different formula here that you're going to use. Again, just before, put a big box around it, yada, yada. Make it stand out. So this formula here, this right one, A divided by P, is to compare the investments, and it's looking at the ratio of the future value, right? Is it 2 times bigger? Is it 1.5 times bigger? Is it 10 times bigger? I'm now also going to include another one here for you, okay? So I want you to actually write this in here. What if I wanted you to find the interest rate? What if I want to find the interest rate? So to find interest rate. Now, again, I can use this top formula here to find it. It's just heck of a lot of algebra though. So bear with me here. This is going to suck. Can I insert an equation here? Hopefully it'll let me. I think I need more stuff downloaded. All right. So first thing I need to do here is it's going to be, so I is equal to, this is going to look a little bit weird. Do, 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 do. So it is something, so this is like square root symbol here, right? So for example, if I were to give you the square root of 25, that would be 5, right? That's on your calculator. Square root of 25. Cool. Sometimes though, I can do like the cubed root. Like for example, I can do, well, I want to know what the cubed root of 27 is. 3 times 3 times 3 is 27, right? So the cubed root of that is 27. So that's what this is here. So I'm going to put n in here. N. So it's being rooted by n. And this is a over p. All of it minus 1. Okay. So make sure you put this in here. So if I wanted to find the interest rate, this is the formula I would use. So there's another one in there for you. Okay. So in order to save you some time, I'm going to jump straight. I'm going to skip example 1, skip example 2. You solve those, figure out what you're trying to find. Example 1 here, how much does she have to invest now? You're trying to find the present value, right? You have the formula for that. What's the ratio? You have the ratio. That's that A divided by P thing. For example 2 here, for example, how much money should they have invested? That's your present value. How much interest will they earn over the growth of their investment? That's your interest there. And, you can look at this, they're looking at the physical amount here, right? They're just looking at the dollar figure. They're not asking for the interest rate. So those are different. Question 3, however, though, Laura has invested $15,500 in a registered education savings plan, an RESP. She wants her investment to grow to at least $50,000 by the time her newborn enters university in 18 years. Okay, so for example 3 here, here's this is on page, I think 38. Yeah. Here's what we know. She invested, we have her present value, $15,500. She wants her investment, A, to be $50,000. And we know that the term is 18 years. So what we want to know is, what is the interest rate? We're trying to find the interest rate here. So if that's the case, I need to use my latest formula, right? This is where it gets a little bit freehand for me, so I'll do my best, right? So I is going to be equal to, all I'm going to do is substitute stuff in. So I is going to be equal, make this bigger for this one. I is going to be equal to, it's going to be, I'll deal with the square root in a second. Right, so the square root of the ratio here, all rooted by n minus 1, right? So that's what this is. So in this case, I is going to be equal to, instead of n, it is, what's n, what's n, what's n? N is the number of compounded periods, right? What would that be? What could that possibly be? Well, doesn't actually say until you read the question further. It's compounded annually. Well, if that's the case, it's compounded annually, right? N is 18 years. There's 18 years times 1, right? It's 18 times 1, right? Because the t is 18. It's only compounded once per year, but it's done by 18 years. So 18, I'll put that in there. Now A My total amount invested was $50,000 divided by $15,000, which is my present value, right? A over P, all minus 1. So throw that in your calculator here. Actually, I want to use this one here. Just actually, yeah, no, I won't. That'll be, you guys have the tutorial for that. So first thing I'm going to do, how do I use this how do I find this? Like, there's no 18, there's a 3. There's just a regular square root button. You need to use this one here. So just how you use this to like put whatever you want to square something, the second function of it lets you put whatever you want to square root it. Now you need to play around with it a little bit. For example, I know it has to be 18 here first. In my calculator, I need to put 18 first. Yours might not need to do that. Play around with it. Spend 2 seconds. If you're really unsure, send me a picture. But so I did 18, second function, my square root button. Now I'm going to do, it's $50,000 divided by 15. So that's about like 3.5, something like that. Oh, backspace. Now this is important. Look at what I just did. The minus 1 is not under the square root. Arrow key, arrow key, arrow key, arrow key. Be really particular with this. Pay attention. This is where you're going to mess it up. Now it's outside of the square root. If I do that, well, that doesn't seem right, right? It's saying my I is 0.0691. Well, remember, that's it as a decimal form. Turn that back into a percentage, right? Move that decimal place over 1, 2. All of a sudden, my interest rate is 6.91%. That seems a little bit more realistic, right? So interest rate here is 6.91%. Double check. Hers is a little bit different than ours, but that is okay. Wait, no, it's not. I know why. I forgot the 500 here. I was like, no, that shouldn't be okay. My bad. So if I do that, it should be corrected here. So it should be actually 672 is equal to 0.0672. Is equal to 6.72% interest rate. Again, even math teachers make mistakes, right? This is why we show our work. That was a very simple error. I just missed the 5. So show your work, and you'll get most of your marks there. All right, so that's question A here. What about question B? So suppose that Laura wants her $15,500 to grow to at least $60,000 with this same interest rate. How long will this take? So what am I trying to find? What am I trying to find here now? So what we're trying to find here is we're trying to find n, actually, right? We're trying to find the number of compounding periods. We know it's done once a year, so we're trying to figure out how many years. Now, the problem with this is that this gets a little messy to do. Even in the textbook, for example, here, like they're not going to be able to do it. This brings you back to this brings you to an entirely different area of mathematics, which is logs, which we don't really need to know about. So you know what? We're not going to worry about B. You know it's going to be at least 18 years, right? You know it's going to be at least 18 years because it took 18 to get to 50,000. You could try and do some like rule of 72 stuff, but generally speaking, if it's asking to find n, we're not going to deal with that in that class. We're not going to deal with that, at least with this formula here, because it does require logs to be able to accomplish. So that's 1.4. So just like before, textbook, do 1.4, skip anything asking to find n, right? Asking to find the length of time. Do workbook 1.4, do the assignment here. All right.